P as principal, initial amount invested or borrower, S as accumulated amount or maturity value, I as compound interest earned, K annual interest rate, M as number of compounding period per year, T as time in years, N as total number of compounding period. Formula used in compound interest. Formula on the left is compound interest formula, S equal P1 plus K the power of MT. And the formula on the middle is compound interest earned, I equal S minus P. And on the right is formula using the total number of period, S equal P1 plus I the power of N.
Next, I will explain question 2 part A. Anita deposited 17,500 ringgit in an account that pays interest at K% compounded quarterly for 3 years. The accumulated amount after 3 years is 28,018 ringgit and 6 cents. We use the compound interest formula where S represent the accumulated amount, P represent the principal amount, I represent the interest rate per compounding period, and N represent the total number of the compounding period. Substituting the given values into the formula, we get 28,018 ringgit and 6 cents equals 17,500 ringgit multiplied by 1 plus K divided by 4 raised to the power of 12. After solving the equation, we obtain K equals 0.16, which is equivalent to 16% per annum. To calculate the interest received, we subtract the principal amount from the accumulated amount. Therefore, the interest received is 28,018 ringgit and 6 cents minus 17,500 ringgit, which equals 10,518 ringgit and 6 cents. Now, I will explain question 2 part B sub part 1. 6 years ago, Wahida took a loan of 7,000 ringgit from a bank that charged an interest rate of 9% compounded monthly. Using the compound interest formula, the principal amount is 7,000 ringgit, the annual interest rate is 9%, the number of compounding period per year is 12, and the time period is 6 years. Substituting this value into the formula, we get 7,000 ringgit multiplied by 1 plus 0.09 divided by 12 raised to the power of 17.2. After performing the calculation, the maturity amount of the loan today is 11,918 ringgit and 18 cents. For part B sub part 2, the interest rate is changed to 8% compounded every 4 months. The maturity amount from part 1, which is 11,987 ringgit and 18 cents, become the new principal amount. Since interest is compounded every 4 months, there are 3 compounded period in 1 year. The loan continue for another 3 years. Using the compound interest formula, we substitute the value into the equation and calculate the new accumulated amount. After calculation, the accumulated amount after the additional 3 years is 15,203 ringgit and 52 cents.
Term used in annuity are as regular payment per period, as future value accumulated amount, P as present value, I as interest rate per period, N as number of payment period, K as annual interest rate, and as number of compounding period per year, T as time in years. Formula used in annuity are 2, and it is present value of ordinary annuity. A equal R1 minus 1 plus I, the power of minus N, and divide by I. For future value of ordinary annuity is S equal R1 plus I, the power of N, minus 1 divided by I.
For the question 4, the accumulated amount for Jimmy investment was RM 87,492.30. If Jimmy deposit RM 1,450 as a monthly investment and was offered an interest rate of 6% compounded monthly, find the number of monthly payment to settle Jimmy's loan. So, for this question, we use the accumulated amount of ordinary annuity formula because it's mentioned earlier in the question, the accumulated amount. Not only that, we have one more formula, which is I equals to K per M. So, what is K and what is M? K is our percent, which is represent the annual interest rate, 6%. as our M is 12 because it represents the number of compounded period. After substitute the value into the formula, 87,492.30 equals to 1,450 multiplied by the quantity of 1 plus 0.06 per 12 raised to the power of n minus 1 all divided by 0.06 per 12. And we got the n is equals to the 53. For question B, buy a condominium for RM 580,000 and she paid 10% down payment. The balance is to be paid in equal monthly installment for 30 years and interest rate is 2.5% compounded monthly. So, for this question, we use the present value of an ordinary annuity formula. A equals R multiplied by the quantity of 1 minus 1 plus I raised to the power of negative n divided by I. So, what is A? A is represent the amount borrowed. R represent the monthly payment. I represent the interest rate per period. And represent the total number of payment. But before that, we have to find the amount borrowed. So 0.10 multiplied by 580,000 equals to 58,000. Next, 580,000 minus 58,000. So we got the amount borrowed, which is 522,000 ringgit. After substituting into the formula, 522,000 equals R multiplied by the quantity of 1 minus, open bracket, 1 plus 0.025 divided by 12, close bracket, raised to the power of negative 360, all divided by 0.025 divided by 12. So, R is equal to 2062.531. Next, find the interest charge. To find the total interest charge, we use the formula I equals N times R minus A. So, for the explanation of the symbol is I represent the interest charge, N represent the total number of payment, R represent the monthly payment, A represent the amount borrowed. Then, we have to identify the value. R is 2062.531, the loan period is 30 years, N is 360, the amount borrowed is 522,000. After substitute into the formula, I equals 360 multiplied by 2062.531 minus 522,000. So, I equals to 220,511.16. Lastly, if N fails to pay the first 3 monthly payments, calculate the total payment should she made if she wishes to sell the outstanding areas on the 4th payment. First of all, we have to identify the values. R equals to 2062.531, K equals to 0.025, M equals to 12, and N equals to 4. Next, substitute into the formula. S equals 2062.531 multiplied by the quantity of 1 plus 0.025 divided by 12 raised to the power of 4 minus 1 all divided by 0.025 divided by 12. So the S is equals to 8,275 ringgit and 94 cents.